Hi everyone, welcome to this workshop. Today we practice on linear inequalities in two variables, and we mainly focus on graphing of a linear equation, a linear inequality in two variables. So first of all, let's go over checking solution to determine the given point is another pair of a solution of y greater than 3x plus 2 or not. So let's go over problem A. They give you a point. We have negative 2 and 4. So to check the solution, we have to do is plug x and y value of the pair of this pair, this my x value and y value, into the inequality problem. So my y will be replaced by 4 and greater than 3x will be replaced by negative 2 plus 2. So we have already give you the true statement. So we have 4 greater than 3 times negative 2 give me negative 6 plus 2. So 4 greater than negative 4. And this one is a true statement. It's true. Then we will say that negative 2 and 4 is a solution of the inequality y greater than 3x plus 2. Okay, so we're going to do the same for problem B. Basically, checking solution, we plug x and y into the equation. So here my x is 5 and the y is 1. So y will be replaced by 1 greater than 3 times x will be replaced by 5 and plus 2, and see are they equal to each other. So we have 1 greater than 3 times 5 give me 15 plus 2, and 1 greater than 17, and which is the false statement. Is false statement, then 5 and 1 is not a solution. It's not a solution of inequality y greater than 3x plus 2. Now let's go into example 1 and see how can we graph a linear inequality. So we have y greater than 3x plus 2. First of all, we need to know this one. If we have greater than or less than, which means not included, so your graph will be a dashed line, or is also called a dotted line. If you have greater than equal to or less than equal to, the line will be a solid line, which means the point on the line is included. So let's graph this inequality. It's like exactly we graph an equation. Since this equation already in the slope intercept form, which is y equal to mx plus b, with m is my slope and b is the y-intercept. Y-intercept is always in the form 0b. Okay, so with that idea, we have slope is the number in front of x, so slope equal to 3. And I'm going to apply rise and run. So I will think this one as 3 over 1. The y-intercept is b with a 2, so y-intercept will be 0, 2. Here we got to graph this one. I will start at 0, 2. This is my first point. And we go up 3 over 1, go up 3 over 1, so 1, 2, 3, and over 1. And keep going 1, 2, 3, and over 1. So send it out my graph. I can also go down and overlap. So 1, 2, 3, and go over left 1. That still give me a point, stay on the line. So we gotta do is connect all the 3 dots together with the dotted line, because the equation is greater than only. So dotted line or dashed line. Okay. So we connect them together. So this is the line of this inequality, but inequality not just stop right there. We still need to find the which area should we shade? Should we shade above or should we shade below of the line? So let's do the test point. As the practice before, to test a solution of an equation, you would choose a point. You can choose any point. Let's say I choose the point 1 and 1. Let's say this is point I'm testing 1 and 1. To see is this point is the solution of this inequality. So put in 1 and 1. We have y greater than 3x plus 2 and replace x is 1 and y is 1 for the equation. So 1 greater than 3 times 1 plus 2. So we have 1 greater than 3 plus 2, and we don't know are they equal yet. Equal or not yet. So we have so 1 greater than 5. 1 greater than 5 versus false. Okay, so since this point is the give me a false statement, so I will shade the area not contain that point. So which means it's above the line. So I'm gonna shade above the line. I shade above the line, so this is my answer. Now let's go over example 2. We have 2x plus 3y less than or equal to 6. So to graph this one, you can use either x and y value table, or you can also use the slope-intercept form. So I prefer to use slope-intercept form. So I need to write my equation in form y equal to mx plus b. So we need to solve for y. So I'm gonna do is isolate the y. So subtract 2x on both sides. So we have 3y less than equal to. As we look at the form, we want x stay close to y, and then the constant should be stay in the back. So which means instead of write down 6 minus 2x, I'm gonna write down negative 2x plus 6. Okay, to make it look right form like the slope-intercept form. Then my next step is divide both sides by 3. Divide all terms by 3. So we will have y less than equal to negative 2/3 x plus 2. Then as you see, my slope is negative 2/3, and my y-intercept is 2 or 0, 2. Okay, I need to write down my slope is negative 2/3, negative 2/3, and my y-intercept is 0, 2. Okay, now let's graph this one. So we will start at the point 0, 2. Always start at this point. We start at this point 0, 2. Okay, then negative 2. So we fall down 2 and go to the right. Go to the right twice, 3 times. Okay, so from this one, fall down 2, 1, 2, and run to the right 3 times. So 1, 2, 3. So that's my second point. And from this point, you can keep going down 2, 1, 2. I'll go to the right 3 units. So we have 3 points. We can connect them together to get the line. So since the original equation has equal to, less than equal to, so with this one tell me my line will be a solid line. So I'm gonna connect them by a solid line. So connect all 3 points. We have this. Don't forget the arrowhead at the ending part. This doesn't look like a straight line. Let's go this way. Okay, that's much better now. Okay, so right now we need to find out is where should we shape above the line or below the line. So we need a test point. So let's write down test point. Test point, you can choose any point to plug into the inequality as long as it's not stay on the line. So let's say if I choose my point is 0, 0. My point is 0, 0. And C is will it give me a true statement or the false statement. If it's true, I will shade the area below the line, which was containing the point 0, 0. If it gives me a false statement, I will shade above the line, was not contain the point 0, 0. So let's check it out. We have 2x plus 3y less than or equal to 6. So I will replace my x by 0 and also my y by 0. So we have 2 times 0 plus 3 times 0 less than or equal to 6. So 0 less than or equal to 6. Which is a true statement. This one is true, 0 less than 6. Then I'm going to do a shade below the line. So we shade the area contain the point 0, 0. And that is my answer for problem 2. Subject, so I have 2 problems for you to practice on. If you get stuck, go back to the example 1 and 2. Make sure you understand the concept. You have 5 seconds to pause the video before the answers show up. So good luck, everyone. So I believe you have your answer already. Let's go over each of them and then see do we have the same answer or not. So first of all, we need to isolate the y, subtract x on both sides. We will have negative 2y greater than or equal to negative x plus 4. Then we need to get rid of negative 2y by divide negative 2y on all the terms. So we have y. That's one thing we need to remember. Right now we divide by a negative number. We need to flip the inequality sign to the opposite one. So which means it's less than or equal to. And negative over negative is positive. So we have x over 2. And positive 4 divided by negative 2 give me negative 2. So now I need to pull out my slope from this equation. So the slope, number in front of x is my slope. Right now we see that x divided by 2. So we don't have any number on the top or in front of x, which means it should be 1. So we have 1/2 is the slope. And the y-intercept is 0, negative 2. 0, negative 2. So now we're gonna graph this one. I will start at the point 0, negative 2. 0, negative 2, which is right here. And we do rise and run. So we rise up 1 and we run 2 to the right. So from this point, I go up 1 and go over 2 to the right. So here's my second point. And I keep going, go up 1 and over 2. And if you want, you can go up 1 and go over 2. You can do this as many as you want. They always give you all the points stay on the same line. So my next step is draw the line, go through all the points. But the problem is, should I use the dashed line or should I use the solid line? If we go back to original problem, you see that we have greater than and equal to. The equal tell me use the solid line. So we're going to connect them by a solid line. Okay. Let's see, how can I make this line straight go through all of them? Okay, here we go. We have one side. Now I need also the same on the other side. Okay, that look good. Okay, now the next part is where should we shape them, above or below the line. So let's do the test point. So test point, So we prefer or we should use the point 0, 0 as long as it's not stay on the line. Because 0, 0 is easy to calculate. Whatever you plug in, you get rid of the coefficient of x and also y. So x minus 2y greater than or equal to 4, and we know x0, y0, so 0 minus 2 times 0 greater than or equal to 4, and finally 0 greater than or equal to 4. So we have 0 greater than to 4, which is the false statement. It's a false statement, so we're going to shape the area not contain the point 0, 0. So which means it's below the line. Okay, and that's the answer for problem 1. Now let's go over problem 2. It's look pretty much the same. We need to isolate the y, so subtract 5x on both sides. Then we will have 3y less than negative 5x plus 9. Then we keep going, divide by 3 on both sides. So you have y less than negative 5 thirds x plus 9 divided by 3 is 3. Then my slope is negative 5 thirds, and my y-intercept is 0, 3. Remember, anytime you write y-intercept, you need to write that as a point 0 and then 3. If you just write 3, it's not a correct answer. That's not a point. Okay. So we will start at 0, 3. 0, 3 up here. This one too light. Let me choose something a little bit darker. So 0, 3 right here. Okay. Then negative 5. So if we fall down 5 units and run to the right 3 units. So fall down 5. So 1, 2, 3, 4, 5. And run over 3. 1, 2, 3. And if I want, I can go down 5 one more time and run over 3. Let's see that out. Let's see. I think it's out the graph. 1, 2, 3, 4, 5. We get 1, 2, 3. So that's my third point. And question again: should we use a solid line or a dashed line? As we see that we just have less than without an equal sign. There's no equal sign, which means it's not includes the point on the line. So we have to use a dashed line, or some teacher will say that is a dotted line. So we use a dashed line for this one. Okay. So next step is, should we shape above the line or below the line? So we're going to use test point. Test point, let's say I choose the point 0 and 0, since it's not stay on the line. So 0 and 0. So plug in 5 times 0 plus 3 times 0 less than 9. So 0 less than 9. That is the true statement. 0 less than 9 is true statement. So we shape the area contain that point. So we shape the area was below the line. And that's the answer for problem 2. So before we move on to graphing linear inequality, there's 2 more ideas I want to tell you about. So first of all, look at example 3. We have y less than 2. So just only y less than 2 without x or anything. So y less than 2. First of all, we need to locate it, that one, y less than 2. Let's say y equal to 2. Where is that one on the graph? So here my y equal to 2 right here. So that will be a horizontal line. it just a line go through the point y equal to 2, and it doesn't cross the x-axis. So we have the line like this. We will have the line go through like that. And I use the dashed line because we don't have the less than equal to. It's just less than by itself. It should be a dashed line. Okay, so the next step is, where should we shade? Above the line or below the line? So as we see that y less than 2 is down here, but let's say if you don't see it, you still can use the test point. So let's say test point, as we always use the point 0, 0. So point 0, 0 right here. So we just have y less than 2, and we have 0 for y, so plug in 0 less than 2. 0 less than 2 is the true statement, so we will shade below the line. And that's the answer for example 3. Now let's go over example 4. We have x greater than or equal to -3, so we need to locate where is x equal to -3. So here my x equal to -3, and with line go through that point, it doesn't cross through the y-axis because we don't have y in the function. So that would be the vertical line. And C, we have the equal to, less than, equal to. Since we have less than equal to, I will use a solid line. Solid line. So we draw a vertical line, go through that point. So the next question is, where should we shade? The right side or the left side? So we have x greater than 3. As we see greater than 3, that will go to the right side. If you don't see it, we can do the same thing, do the test point. So test point. So we use the same point 0, 0 as long as it's not stay on the graph. So 0, 0 right here. Okay. So we have x less than or equal to -3. So 0 greater than or equal to -3, and that is another true statement. So we will shade this direction, shade the right side. And that is the answer for example 4. To close today's section, I have 7 extra practice for you to work on. So have fun, enjoy it. If you get stuck, go back to the example and self-check. You have 5 seconds to pause the video before the answers show up. So good luck everyone. Alright everyone, answer up. I hope that you have correct answer. And as always, thank you for watching, and see you in the next video.